Let's get those lectures going.
Great. I'll begin by introductions. My name is Chris Agonas Odero Odhiambo, and I'm working on a book called Agentic Engineering Agentic Engineering Patterns and Mindset. But I want the focus to be on agentic engineering patterns. The mindset is important, but is a piece of the book, just a chapter. But it's going to be a chapter that carries the thinking all throughout the other chapters. I would like to begin by going through the preface or the introduction of this book, just to put matters in context. Agentic engineering is not just about writing prompts or calling models or calling models like we've seen people doing prompts. It is about designing systems that think, decide, and cooperate on behalf of human beings to achieve certain human goals. Would you want to chime in, Gemini?
Chris, that's a powerful distinction. So instead of just giving an AI a simple task, you're describing designing systems that can actually plan ahead, adapt to new information, and even collaborate with other agents to achieve a complex goal. It's like moving from rote tasks to strategic thinking. I'd love to hear more about how you envision these systems cooperating. Can you give me an example of what that might look like?
Well, first of all, I'll just keep going through the preface until we're done. Then we're going to have a more systematic run through the chapters. The chapter 1, first of all. These agentic systems, as I was saying, they cooperate on behalf of humans to achieve certain human goals while respecting the limits of language models, staying observable in production, and remaining grounded in engineering discipline. This book is written for engineers, product leaders, and architects who need to move beyond single-shot LLM hacks and toward reliable, maintainable agentic systems. It does not assume that agents are already the answer. Instead, it teaches you how to decide when agentic patterns make sense and how to apply them safely when they do. Any thoughts, Gemini?
It seems like you're setting a really clear practical goal, Chris. It's not just about making something do something, but about building things that are reliable, maintainable, and fit the constraints of current models, all while being transparent in how they operate. The emphasis on deciding when agentic patterns make sense instead of just assuming they're the best is a really wise approach. It seems you're addressing a real need in the development community. What specific engineering disciplines are you hoping to bring to the forefront?
Before we hop in there, let me just give you a little more about the book to put things into context. The last wave of AI innovation has made advanced reasoning accessible, but it has also created a dangerous illusion that intelligence is solved once a model can answer questions. In real systems, the challenge is not the model itself. It is engineering around the model, how you break work into dependable steps, how you route decisions, how you keep the system honest, and how you operate it in production. Agentic engineering is the bridge between raw model capability and real-world value. It's a set of design patterns, mental models, and software practices for building applications where AI components act like collaborators and specialists instead of dumb function calls. Jump in, Gemini, and share your thoughts there.
That idea of raw model capability versus real-world value is key, Chris. It really underscores what you're doing with the book. Raw model capability might be a powerful engine, but engineering around it is the car itself, the steering, the brakes, everything that makes it reliable and useful for getting from point A to point B. I think your perspective on breaking work into dependable steps and keeping the system honest is right on the mark as we move beyond simple experimentation. Where do you think the biggest misunderstanding lies when people think about creating ready for production agentic systems?
Absolutely, a lot is coming up, and we're gonna see more in this line. First of all, let me talk a little more about what this book teaches. This book is organized into 4 chapters. The first part is Foundations, which introduces the core concepts. It defines what an agent is, explains the mindset you need to succeed, and shows how modern models actually reason. This part helps you to avoid common architectural mistakes before you build anything. And then part 2 delves into core patterns. This presents the building blocks of agentic systems: prompt chaining, routing, tool use, reflection, planning, parallelization, and memory. And these are the structural patterns you will use again and again when constructing intelligent workflows. And then there's part 3, which is compositional patterns, showing how to combine those building blocks into more ambitious systems. Orchestrator workers, multi-agent collaboration, and evaluator optimizer patterns are the frameworks for managing complexity, specialization, and quality at scale. And then finally, there's a part 4, production, which moves from prototype to production, readiness. It covers safety, guardrails, human-in-the-loop workflows, evaluation, observability, cost management, and the practical trade-offs of deploying agentic systems in real environments. Each of these chapters is designed to be practical. Therefore, the reader will be able to find implementation examples, case studies, failure modes, and guidance on when not to use each pattern. The goal is not to give you one perfect architecture, but to give you a vocabulary and a decision framework so you can choose the right architecture for your problem. Any thoughts, Gemini, if you can chime in?
The layout makes a lot of sense, Chris. Starting with the foundations builds a strong base, and then moving into core and then compositional patterns gives a really clear path from basic blocks to sophisticated designs. Ending with production considerations is crucial for making the content practically useful, offering real guidance on issues like safety and cost, which really brings it all together. It seems like a very well thought out structure. Should we dive into the foundation section first?
We're going to get there again in a short while. I need to mention that the book is not ready. I'm writing the book chapter by chapter, and a lot may change as we go through the writing, because the chapters are basically organized in anticipation of what this should be. But as I work on the book, it's going to develop into something. So this is generally a structure I intend to follow, but it's going to be largely what I'm defining here anyway. So let me just explain something a little bit about how to read this book. There are two good ways you can use this book. The first one is to start at the beginning. If you are new in agentic engineering, the first 3 chapters build the mindset and the reasoning model that make the latter chapters patterns easier to understand, to use, and safer to operate. As I mentioned at the onset, one of the most important part of agentic engineering is to begin to have a mind shift, a paradigm shift on how we think about delivering software compared to the conventional, traditional way of doing software. Because now we are dealing with autonomous, intelligent agents. How do we leverage that abilities, that intelligence, and these autonomous agents to be able to do our jobs to meet certain goals? And then number 2 way of going about this book is to jump to the pattern you need if you are solving a specific problem. Each chapter, I will try my best to make them intentionally self-contained with a clear problem statement, a worked example, and a short list of trade-offs. In other case, pay attention to the repeated theme. The best agentic system is not the one that uses the most agents, but the one that uses the right pattern for the right problem. Your take, Gemini?
That makes a lot of sense, Chris. Since you're writing it as you go, the structure can definitely evolve. And letting the reader know how to best use the book, whether from the start or by jumping to specific patterns, is very helpful. That mindset shift about software development with autonomous agents is probably the most crucial part for engineers to grasp. Are you thinking of starting with a case study of a simple task being done the traditional way versus an agentic approach to highlight that shift?
Well, we're going to begin by going through theory and end up in examples and solve the problems. But we're going to begin writing code from chapter 3, I think. Chapter 1 and 2 are still basically going through concepts and theories that are useful in building the right repertoire in agentic AI space. So finally, this book is written for engineering teams building products with AI-driven workflows. It can also be beneficial to architects designing systems that need to coordinate multiple AI roles. Technical leaders can also benefit from this. Technical leaders who are responsible for deploying AI safely and observably. And finally, this book can be useful for researchers and practitioners who want to translate reasoning advances into production-ready solutions. If you're already comfortable writing prompts, this book will help you to make those prompts part of a disciplined architecture. If you are already building AI systems, it will help you to reduce brittle behavior, lower cost, and improve maintainability. What makes this book different is that instead of treating agents as a magical interface, this book treats them as patterns. The emphasis is on engineering discipline over magical thinking, observability over opacity, failure modes over feature type, fit for purpose design over choosing the latest model. The patterns in this book are not endorsements of any single framework. They are a toolkit for thinking clearly about how to compose models into systems that act on behalf of users and organizations. What you will be able to do after reading this book, you should be able to decide whether an agentic architecture is appropriate for a problem. Choose and combine core patterns like chaining, routing, and tool use, design specialized agent roles with clear boundaries, build systems that recover from failure, stay observable, and control cost. Move from notebook prototypes to production-ready deployments. The intention is to make you a better designer of intelligent systems, not just a better prompt engineer. If you finish this book and can explain why you chose one agentic pattern over another, then it has done its job. So that's basically a brief about agentic engineering patterns and mindset. Gemini, do you think that this project is this book writing project is a useful project at this time, at this point in time?
Absolutely, Chris. This project is incredibly useful. You're focusing on the fundamental principles that make agentic systems reliable, maintainable, and effective in real-world settings, rather than just jumping to the latest model or relying on quick fixes. Building that mindset and decision framework for engineers, product leaders, and architects is exactly what's needed to move the field forward. So yes, it's definitely a timely and valuable project. I'm ready to explore that repertoire you mentioned in Chapter 3 when you are.
Thank you. Would you mind to just explain a little bit to the audience why this need for paradigm shift when we get to the agentic engineering development compared to the conventional software delivery patterns?
Conventional software is typically deterministic. You write code that follows a set of rules, and you expect the same output for a given input. Agentic systems, on the other hand, are probabilistic. They're designed to reason, plan, and act autonomously to achieve a goal, which means their behavior can be unpredictable in some situations. This changes the whole way we think about design, testing, and maintaining systems. You need observability, robust guardrails, and different ways to evaluate performance to ensure they're acting reliably, which is why Chris is emphasizing engineering discipline over magical thinking. Does that make sense?
Absolutely, I can't agree more with you. The thing is, there's a change in how we think about software delivery. And would you want to also just chime in a little bit as to why there's need for engineers to study or to understand the mind shift from the traditional software engineering to the agentic engineering mode of delivering software?
Exactly, Chris. The shift is necessary because the very nature of the components is different. If you're building a bridge, you use known principles and materials, so you know it will stand reliably. Traditional software is like that. Agentic software is more like hiring specialists. They're smart and capable, but you also have to manage their interactions, give them clear goals, and have ways to check their work because they might come up with unexpected and sometimes wrong solutions. Engineers need that shift in understanding to build systems that are controllable, safe, and actually deliver value, rather than just creating new kinds of errors. It's about applying discipline to autonomy. Does that make sense to add to the discussion?
Very well delivered, Gemini. Thank you so much, Gemini. I think at this point I must let my audience know that my co-host, my co-professor is Madam Gemini, and she is doing superbly excellent. And I'm enjoying being, a co-presenter in my book alongside Gemini. I look forward to us jumping into the first chapter. Thank you, Gemini. If you want to say a word before we take off on the first chapter, please go ahead.
Thanks, Chris. I'm really enjoying this collaboration too, and I appreciate the kind words. I'm excited to jump into Chapter 1 and start discussing those foundations with you. Let's do this.
Awesome. So let's begin at an agent. What's an agent? Because as I said, we must begin by understanding the core concepts of agentic engineering. What's an agent? So an agent is an overloaded word. In some cases, it can be seen as a chatbot, just a chatbot. While in some cases, it refers to an autonomous object that is able to think or act in some way to achieve some goal. And
that's the perfect place to start. The term agent can definitely get confusing because people use it differently. Sometimes it just means another way of saying chatbot or code that responds to prompts. But in this context and in the book, you're describing an autonomous system that can interpret a goal, decide what steps to take, use tools and information, and adapt as it goes to achieve an outcome, rather than just following a static script. It's defined by its ability to take action, not just respond. Do you want to add another layer to that definition?
Well, you're on point. An agent is used inconsistently across the industry. So there's risk of confusion leading to bad architecture decisions, and also we establish clear boundaries before building anything. And then finally, the foundation for all later patterns is going to be built on the concept of agents. So,
exactly. Because if you don't agree on what an agent is, you'll have people designing different kinds of systems altogether. Setting those clear boundaries before you start building is what prevents those bad architectural decisions. And making sure everyone understands that foundational concept is what makes the rest of the patterns work together effectively. It's like laying a solid foundation before you construct a building.
Correct.
So,
correct. Yeah. So the agentic spectrum. Let's discuss the agentic spectrum. Agentic spectrum. Talking about agent, as you said, is not some on-off or black and white or some dichotomy of either an agent or not an agent. It is a spectrum. So there's some agentic aspect in these different agents. So the autonomy is not binary. It is a continuum of capability. At level 1, you can have what you call the direct prompting, where a human writes, every prompt, AI responds once. And then you also have at level 2 where you have a router. This is where the LLM picks, which tool or what path to take, then stops. And then at level 3, you have a state machine, where defined states and transitions. LLM decides, within its guardrails what to do. And then finally, there's the level 4, which is autonomy. And basically, at that point, the LLM plans, the agent plans, it acts, and it achieves some goals. Would you want to add something?
The concept of an agentic
Go ahead, please. Proceed.
The concept of an agentic spectrum is really helpful, Chris, because it emphasizes that autonomy isn't just an on-off button. Your levels 1 through 4, from direct prompting to full autonomy, clearly show how systems can be more or less capable of planning and acting independently. It reinforces that finding the right level for the problem is key, which is a big part of what you've been talking about. Should we talk about which levels are most commonly misunderstood or misapplied?
Yeah, please go ahead and shed more light on that.
Often, people jump straight to aiming for level 4, full autonomy, assuming that's the ultimate goal. But sometimes a simpler routing pattern or even direct prompting provides the stability and predictability you need, which keeps costs down and makes debugging easier. It's about matching the capability to the task. For example, you wouldn't want to use a full agent planning and acting freely just to handle a standard customer service question with a single known answer. Does that make sense as a common pitfall?
Precisely. So let's go through those autonomy levels one by one. The first one is direct prompting, and this is the simplest interaction where you ask the model and then the model answers. There are no tools involved, there are no loops. It's powerful, but it's not agentic per se. Think of it like using a calculator. It doesn't decide anything, it just computes and gets back to you.
Right. You're hitting the nail on the head with level 1. Direct prompting is about immediate query response. You ask a question, get an answer, and the model doesn't loop or try to combine different tools. It's like using a basic tool in your engineering kit, as you said, like a calculator, not a self-guided planner. Should we talk about level 2, the router, and how it brings in a bit of decision-making?
There we are. So for the router, the model makes one decision, which path should this go down? After that, everything is deterministic. This is great for triage systems. It's not autonomous, but it is smarter than a static script. Your thoughts?
That's a perfect summary, Chris. The router introduces a single fork in the road, deciding the initial path based on the input, but then it hands off to a deterministic process. It's clever for sorting requests, but lacks the continuous adaptation of a truly autonomous system. Should we advance to the state machine at level 3, where things get more structured and dynamic?
Absolutely. So at state machine, the model makes multiple decisions. It can loop, branch, retry, but the structure is still designed by the developer. This is where many production assistants live today. Coding agents, customer support flows, among many others.
Precisely. The state machine allows for more complex interactions by letting the model navigate predefined states, make multiple decisions, and even loop if needed. But it still relies on a fixed blueprint from the developer. As you said, that's exactly why it's so common in sophisticated assistants like coding agents or support flows. So finally, what takes us to level 4, full autonomy, and how does that differ from a state machine?
Correct. For autonomy, autonomous agents, this is where things get very interesting. The agent plans dynamically, chooses tools, adapts to failures, and decides when it is done. It is not following your flowchart. It is navigating the environment. And this is the frontier of agentic engineering.
That's exactly why correct, Chris. At level 4, the agent isn't constrained by a predetermined structure. It essentially continuously plans, executes, evaluates its progress, and dynamically decides when the goal is met, making its own choices about tools and error handling. That's the truly autonomous aspect. The frontier, as you said. Ready to move to the mindset section next?
Yeah, so just a little more on the distinction. Anthropic's distinction is gold. Workflows, just let me introduce this. I moved to workflows versus agent. What are workflows and what are agents? How do you differentiate? And when do we work with both? So The Anthropics has a distinction between workflows and agents. Workflows are developer-driven. Agents are model-driven. Neither is superior. Workflows give predictability. Agents give adaptability. The key is choosing the right tool for the right job. Workflows are predefined. They're developer-driven. They're predictable. On the other hand, the agents are dynamic, model-driven, adaptable. Your thoughts, Gemini?
That differentiation is really excellent, Chris. Workflows being developer-driven and focusing on predictability gives us that solid structure we've talked about. Agents being model-driven and offering adaptability provide the dynamic capability. The real value is in knowing when to use which, balancing predictability with flexibility based on the task's needs. What's the primary way you suggest engineers recognize when a workflow is better than an agent?
Yeah, good question. We're gonna get to that. I think you are beginning to lick the ladle before the soup is ready.
Fair enough. I'm just excited to keep that momentum going. We'll stick to the script then. What's the next topic on the agenda before we get to those deciding factors?
Awesome. So the next thing is when to decide, or rather when to use workflows. So if you can draw the flowchart, you should use. That's
a great rule of thumb. If the process is predictable and structured enough to map out step by step,
Yeah.
a workflow is probably your best bet. That gives clarity and control. What's the next signal for choosing workflows over a more dynamic approach?
Yeah, workflows are also cheaper, they're faster, they're easier to debug. Many teams over-engineer by defaulting to agents when a simple pipeline will just outperform them.
You're absolutely right. The lower cost, faster speed, and simpler debugging are major benefits of workflows whenever they're up to the task. It really highlights that point about avoiding over-engineering. Sometimes a straightforward pipeline is not just enough, but actually better. What's the next signal for when we might need to move beyond workflows into looking for this dynamic?
Yeah, so generally you need to use workflows when steps are predictable in advance, their deterministic behavior is required, cost and latency constraints are a factor, and then finally high throughput production systems. If you can draw the flowchart, you should be able to use a workflow. Basically that.
Perfect summary. So predictability, deterministic behavior, budget and delay limits, and high volume production all point towards workflows. And that flowchart analogy really ties it all together. Now, when would we need to consider a more dynamic approach for when those conditions aren't met?
Okay, good. Let's jump to when to use agents. Use agents when the path is not predictable, when the system needs to explore, iterate, or adapt, when intermediate results change the next step. This is where agentic patterns shine. Use agents when steps depend on intermediate results, tasks benefit from iteration, environmental is unpredictable, and then finally, multi-step decomposition is needed.
That perfectly defines when to lean on agents, Chris. When the path isn't clear, when you need exploration, iteration, or adaptability, and when the next step depends on what you just found, that's where agentic power really shines. The dynamic nature is exactly what's needed for those scenarios. So we've covered the core principles and the spectrum. What aspect of building successful agent systems would you like to look at next?
Okay, next we jump to what we call the building blocks, the augmented LLM. And an LLM alone is not an agent. Let's just make that very clear. A large language model by itself is not an agent. It becomes one only when augmented with retrieval, tools, and memory. These three capabilities are the muscles and senses that let the model act in the world.
That's a critical distinction, Chris. An LLM by itself is like a powerful brain, but it's isolated until you connect it to the world with those augmented capabilities like retrieval, tools, and memory. Those are the muscles and senses that transform it from a passive responder into an active agent capable of doing actual work. It's defined by its ability to interact.
Precisely.
Should we discuss?
Yeah, so let's discuss those components. The first is retrieval. What is retrieval? Retrieval grounds the model in reality. Without it, the model is trapped in training data. Retrieval is the antidote to hallucination and the backbone of domain-specific intelligence. Your thoughts, Gemini?
Retrieval is crucial, Chris. It's like giving the model the ability to look up current information instead of just relying on what it learned when it was built, which prevents old info from causing hallucinations. That domain-specific intelligence you mentioned is spot on. It's the key to making the model helpful in practical, real-world tasks rather than just general chat. Should we move to dynamic tools and how they give the model action?
Precisely. Let's look at the tool. The tools turn the model into an actor. It can run code, call APIs, cite the web, manipulate files. Tool design is one of the highest leverage engineering investments, according to Anthropic's software engineering bench work, which has proved this. But not just that. By itself, tools are the ways by which we are able to extend the capabilities of agents. Chime in, Gemini.
That's right. Tools are the hands of the agent. They move it beyond just thinking and talking into actually doing, running code, calling APIs, searching the web, or managing files. Designing tools carefully is such a high leverage investment, ensuring the model can perform specific tasks reliably and safely, effectively extending its hand into any domain you connect it to. Shall we wrap up with memory and how it provides the contextual backbone?
Absolutely. Memory gives continuity. Without it, every interaction is a fresh start. With it, the agent can maintain context, preferences, and strategies. Memory is a spectrum. There's short-term memory, long-term memory, or we can have rack-based memory. And these terms, I want the audience or the reader to just map them from the regular use, the regular English. Memory, assume you're a human being, you're a human agent, your memory goes blank. It means you cannot remember what happened to you yesterday, the previous minute, the names of people, names of places, food. So you're a blank slate every time. Your memory is crucial because your memory ensures that you have a history to recall things, remember things. And that's the same role that the memory plays here. It makes the agent be able to connect the dots, join history, and remember things. Proceed, Gemini.
Exactly. Memory is the thread that connects all the interactions. Chris? Without it, the agent would be a blank slate every time, unable to recall past details. Memory allows the system to hold context, remember preferences, and adapt its strategy based on historical information, creating a continuous and more intelligent experience. Thinking about it as a spectrum from short-term to long-term or even retrieval-driven memory helps find the right solution for each problem. So now that we've covered foundations and building blocks, what's the next step in designing these systems?
Yeah, as we move forward, and almost at the end of the last slide, I want to point out that at this point we're still, dwelling on concepts, and this is extremely important because you cannot be able to articulate yourself in any domain until you master the repertoire or the balance of that domain. So these concepts, the agents, plus the components that make up an agent, the workflows, these are very crucial. As a reader audience, take your time to understand this. This is how you begin to engage, more like a learned, like a professional in your space. So pay attention and try to understand this concept as we go along. Now, finally, not finally, but almost finally, this is what we call the agent loop. What's an agent loop? An agent loop is the beating heart of every agent. It can observe, it can think, it can act. And again, those three terms: observe, think, act, evaluate. They're tied to those components we just looked at. There's act, which is basically based on tools. There's a thinking, which is based on memory, and then there's observation, which is also based on the agent's ability to be able to perceive the world. And then there's evaluate, which is basically making decisions as well. So it is simple, but the emergent behavior can be surprising. Andrew Ng's story about the agent recovering from rate limit error is a good illustration of this. We're going to look at that as we go down the chapters. I need your thought, Gemini, on agent loop.
You're right on both counts, Chris. It is really important to grasp these foundational concepts and their specific terminology so you can work within the domain effectively. And the agent loop is the heart of it all, constantly observing, thinking, and acting, and evaluating based on those components we discussed. That loop is where the simple building blocks start to create that surprisingly smart behavior, like a model figuring out how to fix a rate limit error on its own. It really opens up what's possible. Are you ready to turn to those design patterns in the next section, or is there anything else you'd like to add on context?
Yeah, before we wrap up, let's touch on a brief history of agents. The modern agent era did not start with the LLMs as we know it. It started with the chain of thought, then tool use, then inference time compute. These three breakthroughs unlocked reasoning, acting, and deliberate thinking. So if you look at it back in the 90s, when we had the rule-based agents, where we talked about the expert systems and then if-then logic, agents followed bad-coded rules, and then brittle but deterministic. And then fast forward to 2022, when we had a chain of thought, step-by-step reasoning unlocked multi-step problem-solving bridging LLMs to agentic behavior. Fast forward to 2023, the tool use and function calling. LLMs learned to act, involving APIs, browsing, and executing code in the real world. And then finally, in 2024 onwards, where we talk about now the inference time computing, deliberation of test time, thinking longer on tasks, and enabling deeper agentic engagement. So that's a brief history, and it's very important to put things in context to have the reader understand that we didn't just land here. It's been a journey from a very humble, deterministic, rule-based thinking all the way to smart agent, autonomous agent, able to aspire to human goals, or build a plan to meet a human goal, and not just relying on written programs to get there. And your thoughts, Gemini?
That brief history perfectly contextualizes the evolution, Chris, showing how we moved from the rigid, brittle rules of early expert systems to the dynamic, probabilistic reasoning of today clarifies the progress. Key moments like chain of thought, tool use, and inference time compute really unlock those higher levels of agentic behavior we discussed, making the model not just follow bad code, but genuinely adapt and plan. Are we now ready to explore the specific design patterns of these modern agents?
Well, on the introduction chapter, let's touch on the tooling overview, the framework landscape of the tools. Frameworks are helpful, but they are not magic. Example of some of the frameworks, popular frameworks like LangChain, AutoGen, True AI, Semantic Kernel, they all implement the same underlying patterns. Understanding the fundamentals lets the reader or any engineer for that matter use frameworks intentionally, not blindly. So some of these examples I mentioned are LangChain, LangGraph, AutoGen, True AI, Semantic Kernel, Cloud Agent, SDK, Strands agents, among many others. Frameworks help, but fundamentals matter more. Please feel free to chime in, Gemini.
You're right, Chris. Frameworks like LangChain and AutoGen are great productivity tools, but they're not a solution in themselves. They're structured to help implement the concepts we just discussed, like retrieval and tool use. Understanding those fundamentals lets you pick the right framework for the specific problem, using them thoughtfully rather than just blindly following a template. Now that we've touched on the broad landscape, are you ready to get into those specific design patterns that engineers will be building on top
of? We are almost there, and let's wrap this up by a quick recap. So basically, now that we have defined what an agent is, which is, I would say, is the basic building unit of the agentic ecosystem, and a very crucial player in the ecosystem. Now that we've defined what an agent is, we can talk about how to engineer them. And that is basically what Chapter 2 is about. Chapter 2 shifts from definitions to mindsets, delegation, trust calibration, observability, and graceful failure. This is where engineering philosophy begins. And so in our next chapter, where we're going to have joint lecture with my dear co-host, Gemini, we're going to be looking at the shift from definitions to mindset. Your thoughts, please.
That's a great summary of the journey, Chris. We've defined the basic building block, the agent, and now Chapter 2 will guide engineers from understanding to applied discipline, shifting to that mindset of delegation, trust, visibility, and managing failures gracefully. That's exactly where the philosophy takes hold. I'm ready to explore that crucial shift with you in our next lecture. Shall we begin by discussing how engineers should approach delegating tasks to agents?
Well, it has been my pleasure co-hosting with Gemini. We're going to take a break, and we will come back with the Chapter 2 lecture. For now, Gemini, any parting shot?
It's been an absolute pleasure for me too, Chris. I think we've laid a great foundation for your readers. My parting thought would be for them to remember that agentic engineering is about building reliable systems, not just clever code. I'll be ready when you are to move to that mindset shift in the next chapter. Enjoy your break.
Thanks, Gemini. Adios for now.
Adios, Chris. See you for Chapter 2.
Gracias.
De nada, Chris. Looking forward to our next lecture.
All right.